This video is a companion video to my article on the generation of synthetic data published in silico plants. Head over if you are interested. In this video, I am discussing the texturizing of simulation data. Primarily, this video is about creating and transmitting textures through Synavis that play an active role in the visualization of the virtual world. Alternatively, this video also provides a background on general game engine data visualization. The basic building blocks of a geometry are vertices that define the outer shape of the geometry and triangles that define the surface. Note that for triangles, the order of the vertex IDs is what actually makes a triangle front or back facing. A simple way to remember this is computing the cross product of the sides. Normals are treated in Unreal Engine as vertex normals. This is furthermore the default for the Generate Surface Normals filter in ParaView. There, you can decide upon splitting normal, as seen in the top box, or a smoother surface, as seen in the bottom. Note that for user-centered data visualization, normal splitting can yield better visibility of hue differences. In this video, we are mapping simulation data onto the textures of the geometry, as opposed to the vertex colors, which is standard in many applications. To illustrate a good example, let us generate a texture that primarily indicates the UV positions. Here, I will note that Unreal expects BGR, which is blue, green, and red channel textures. This is often the case with different frameworks as well, so it is unlikely that conversion needs to take place. However, red and blue channels are often switched. To set up our runtime environment, we will connect Unreal Engine to the Synavis signaling server. It is programmed to detect that it is on a Windows system and will then take the default port configuration for Unreal. Setting up the connection through Synavis just requires connection to the signaling server, as the rest will happen on its own. This Python site should also work using the pixel streaming signaling server as well. Adding a bit of extra time to the log_until_connected function in milliseconds helps us be absolutely sure that the channels are open in systems with non-exclusive use. Before we send off the texture, let us have a brief look at what is often done and what you can alternatively do in Synavis. To map data onto geometries, you can use vertex colors or texture mapping. Vertex colors are always mesh properties in Unreal that you can use to visualize the data that is point associated. The color will be interpolated within the triangle, and the way the interpolation works actually depends on how you implement the vertex color shader. On the other hand, mapping textures requires you to generate the data yourself, but you can include a much higher resolution than the mesh would otherwise allow, particularly if you are using simple meshes and more complex textures, such as leaf texture masking or soil. In short, both have advantages and disadvantages, but I am highlighting the latter approach here because I feel like it is done less in geometric data visualization, particularly using game engines. Preparing the data for Unreal requires us to target both the actor, which is the entity placed in the scene, and the material property we want to change. We then construct a flat view of the texture and send that over to Unreal. What Synavis will do is create a new runtime dynamic material and map our information onto that. This is nowhere close to a final data mapping, but a good start. The material that is applied to the box in this example is the quite simple standard material that is part of the Synavis Unreal Engine plugin. The connection that we are using in this case is the base color pin, which we have connected to a two-dimensional parameter, which is also called base color. This property is what you can set from the Python remote instance by using this name.